Hello, this is Mr. Harris, the Polynomials unit. I'm covering pages 24, 25, and 26. We will first review polynomial division, and then we will work through the rational root theorem. In the last unit, rational functions, there were several Khan Academy videos assigned where you had to divide, so I hope you practice division then. Regarding me and my class and polynomial division, there's long division and synthetic division. I don't care which one you do, pick one and be good at it. I stick with long division because it reminds me of dividing in elementary school. Plus, there aren't tricks you have to remember. It's very straightforward. For example, here you have x to the fourth, x cubed, x squared, x to the first, x to the 0 power. Because yes, it is 2 times x raised to the 0 power. Let's say this x squared was missing, you would just interject a 0 times x squared term and you can continue dividing. Synthetic division, there's steps to remember. However, for some reason, a lot of college professors like this. It is less steps, I guess. If you choose synthetic division, make sure you Khan Academy out, do it, double check, make sure you do what you need to do, such as life. If you want me to work any of these using synthetic division, please show up to a tutoring section and I will work through with that. But you have this, you have an example of using synthetic division. I'm going to work through 1A. Because you had Khan Academy videos where you had to divide, I'm going to go ahead and make B a simple quiz. No, I won't do that because some of you may just want the extra practice. There will be a quiz based off of this, but I have other questions I could pull up. So this we're going to work through. Then we're going to jump to the rational root theorem. This is the cubic formula. It's long and cumbersome and not always reliable. So the rational root theorem is what we use to solve more complicated equations beyond a quadratic function. We're going to practice, and then we're going to have a simple quiz where I will post a question, and I'm going to make it multiple choice. What is the correct answer? All that good stuff. Expect to be assigned your test sometime next week around Thursday. It will be assigned Thursday. You will have until Monday to submit the test. But let's just begin with practicing dividing polynomials. Okay. Dividing polynomials is relatively somewhat similar to actual division you did back in, what was that, 3rd grade, 4th grade? Let's say I'm dividing 8 divided by 214. Just as a reminder, in fraction or rational form, this would be 214 divided by 8. So I was told you kick the numerator down into the little house, and that's how we remember we divide. So we know it's going to be that this is divided by that. I'm just going to show through what I worked. It doesn't make sense to work the whole thing out. When we divide, it's 8 doesn't go in there, but 8 goes in there, all that good stuff. We're subtracting, we're bringing down values. We have the remainder. We can write it like this, 26 remainder 6. We could also write it like 26 fraction 6 divided by 8 as a mixed number. We can simplify this 26 and 3/4. All that good stuff. It's somewhat similar to this. So let's just work through number 1, or 1A, I guess. This is divided by that, so we're going to kick the numerator. You could also call this dividend divisor, all that stuff, quotient, or the numerator denominator of the fraction. But it's going to be x minus 2 divided by 2x cubed minus 5x squared minus 3x plus 6. So let's divide this step by step by step. In this case, to divide, first of all, we need to make sure it's in descending order. The powers of x are in descending order. X cubed, check, x squared, x to the first. And just the constant term, that's essentially 6 times x raised to the 0 power. 3, 2, 1, 0. Voila, good job. We don't need this x to the 0 power because it just turns into Mr. Sneaky 1, and Mr. Sneaky 1 is invisible. But let's divide. The first step to divide, step 1, we have to figure out what do we have to multiply x by to get 2x cubed. X times x is just x squared. X times x times x is x cubed, so we're getting there. If I throw a 2 in, x times 2x squared, I get 2x cubed. So we have to multiply x by 2x cubed, or 2x squared, shame on me. So x times x is x squared, x times x times x is x cubed, x times 2x squared is x cubed. So we have to multiply x by 2x squared in order to get 2x cubed. So x times 2x squared is 2x cubed. So what I'm going to put here is 2x squared. Whatever we have to multiply this by to get that is what goes up here. And then what do? We multiply this by the x and this by that minus 2. So x times 2x squared is 2x cubed. Negative 2 times 2x squared, so that's minus 4x squared. Now we have to subtract just like we subtracted with long division, just like we subtracted here. Minus, always plug in your parentheses. And now I have to distribute that negative sign. When I distribute this negative 1, this becomes a plus sign, this becomes negative, and this becomes a plus sign. You have to make sure you change your signs, but however, there's a good fail-safe or quality control check procedure here. When I add down 2x cubed plus negative 2x cubed, I get 0x cubed. If you don't get 0x cubed, you know you made a mistake. So that's why it's good to check this. And that's why we have to think about this times that equals that. So when we subtract it, it cancels out. Now we add straight down here, negative 5x squared plus 4x squared. So that's minus 1x squared. And that's why we have to make sure the powers of x, or whatever x is raised to, is in descending order. So we have something we can combine with this, combining like terms. So once we have this, we can cancel that out. I'm going to draw my arrow to bring this down. Minus 1x squared, same thing as negative 1x squared. Minus 3x, I might as well plus 6. So now we begin that cycle all over again, except now we have to address negative 1x squared. Same thing. What do I have to multiply x by to get negative 1x squared? Minus x. So we have 2x squared minus x. Negative x times x leaves me with negative 1x squared. So we do the same thing. We multiply negative x times that and that. This becomes negative x squared plus 2x. You notice now we can combine it with this. Minus parentheses. Let me get my red pen. I like using a different color because it just helps me make sure I don't make careless mistakes. And you have to keep track of these negatives. And we know this works because this negative 1x squared plus 1x squared yields 0x squared, so it's canceled out. Negative 3 plus negative 2, that's negative 5x plus 6. Do the same thing again. What do we have to multiply this x by to get negative 5x? Negative 5, so we have minus 5 up here. So we have negative 5x, negative 5 times negative 2 is negative 10. Subtract parentheses, plus, plus, plus. Cancel, cancel, so you know we did the right thing. Positive 6, positive 10 equals positive 16. There's nothing else we can do. So we have to, if we wanted to go further, we could say, well, what do we have to multiply x by to get 16? x times 16 divided by x equals 16x over x, which just leaves us 16. So you could deal with this, but once we get to the point where we have a rational function, where x is in the denominator, there's no point in going on. We're in the realm of remainders. So I would just say the remainder is 16. This is one way to write the answer. Just like with fractions, we could say the remainder is 6 in this case, or we could write it in terms of a mixed number. So one potential solution is this cubic function divided by this linear function becomes a quadratic function, 2x squared minus x minus 5. And if you notice, if you divide a function by another function, it drops in degree. So if I'm dividing a cubic by a linear function, degree 1, it drops a degree to a squared function. And that's how it is. Another way to write this function is 2x squared minus x minus 5, because 16 is positive, plus 16 divided by this x minus 2, because we're still dividing, just like in the original. And this is a nice way to write divisors. I'm okay with either saying this remainder 16 or this plus this. You can type this in the Desmos and graph it. You can't really type that in the Desmos and graph it. But that's how you divide rational or divide a polynomial function. If you're curious, go to Desmos Graphing Calculator and graph this. Ultimately, it would be with this rational component. But it's interesting to look at. So this was number 1A. I'm going to work 1B. I highly suggest you practice 1B completely on your own, and then just verify. Again, the solutions to this will be posted online. So let's just do 1B. Remember, you can pause. You can play my videos at 1.5 the speed, 2 times the speed, whatever works for you. I'm actually going to go to a fresh page. So I'm going to divide for 1B. I'm going to divide this using long division. If you want to use synthetic division, use it. For God's sakes, use it. Whatever works, work it. I'm like, pick one method and stick with it. So we have 1B. So it's going to be x plus 4 divided by 3x to the 4th plus 10x cubed plus 30x plus 3. And I'm going to divide these. The step is, what do I have to multiply x by to get 3x raised to the 4th power? Well, 3x cubed. Test it out. X times 3x cubed equals 3x to the 4th. So that's what I have to multiply x by. So down here, I write down this times x plus this times that. So I have 3x to the 4th plus 12x cubed. And in doing this right now, I see, yes, I can combine these like terms. So the parentheses in. I can combine these because they're both x cubes. However, I see there's a problem going on. 4, 3, there should be a 2, 1, 0. So I'm going to change this. I'm going to interject a 0x squared. So we have plus 0x squared plus 30x plus 3. And I didn't really change it ultimately. This is still 0. It's just once I divide and I end up with an x squared term, I'm going to have something to combine it with, and I won't end up in this quagmire. So let's subtract these. Plus, minus, minus. Keep flip change. This cancels out. Good job. Positive 10 and negative 12 leaves me with a negative 2x cubed. Let's bring everything down. Plus 0x squared plus 30x plus 3. You don't have to bring everything down at once if you want to use arrows. I'll do it another way where you don't have to necessarily bring everything down at once, but you have to make sure you remember. So I have negative 2x cubed plus 0x squared. Here we go again. What do I have to multiply x by to get negative 2x cubed? I have to multiply x by negative 2x squared. Negative x times negative 2x squared leaves me with negative 2x cubed. 4 times negative 2x squared is negative 8x squared. Plus, oh, sorry, shame on me, what's wrong with me? We're subtracting just like division in elementary school. We're going to subtract those two, but we're going to have to distribute this negative 1. So when I distribute the negative 1, it changes the sign, changes this to addition, plus, plus. We know we did the right thing because negative 2x cubed plus positive 2x cubed cancels out. When I add these, I get 0x squared. I'm going to bring down plus 30x. What do I have to multiply x by to get ax squared? Well, plus 8x. So when I multiply 8x squared, 8 times 4 plus 32x minus subtraction signs. Plus negative, negative. This cancels out. We're left with negative 2x. Let's remember to bring down this 3 plus 3. What do I have to multiply x by to get negative 2x? Minus 2. Negative 2x. Negative 2 times 4 is negative 8. We're going to subtract these. Plus, plus, plus. Cancels out. 8, 9, 10, 11. So our remainder is 11. Let's write this another way. 3x to the 4th plus 10x cubed plus 30x plus 3 divided by x plus 4. That also equals 3x cubed minus 2x squared plus 8x minus 2 plus 11 divided by x plus 4. This is another solution. Wonderful. I'm just going to have a multiple choice, which is the correct answer after you divide it. I'm going to type this into a TEDx or a TED-Ed function. So as I'm typing it in, it might look something like 3x caret 4 plus 10x caret 3. Just to keep things simple, I will probably go ahead and throw them in parentheses. So this caret divided by slash parentheses x plus 4 equals what? The solution will be something like that. Expect this to be divided by, for example, it'll be 3x caret 3. I actually think they do have superscripts. So it will probably be something like that. However, your answer, actually multiple choice, you won't have to type in an answer, you'll just select the right answer. So be on the lookout for that. Email me if you have issues. And that's it for 24. Again, the solutions will be posted. Hopefully you worked 1B out on your own, and then either you check with the video or with the PDF with the solutions. On to page 25, where we are going to work the rational root theorem. Again, the rational root theorem is required so we can solve more complicated polynomial functions. This is the cubic equation. Just like we have a quadratic equation, we have an equation to solve cubic functions. It only solves cubic functions, and look at how complicated it is, and then it's not completely reliable as well. However, no one wants to, for God help people who made a quartic equation, centric equation, septic equation, sestic equation. I went to 7 before 6. No one has time for that. So there's thankfully a better way to solve quadratic equations that doesn't require all of this. Look at it, BC divided by 6/8. No. However, one of the best ways is simply graph and get the roots of the solutions. Solving complex polynomial equations, mind your P's and Q's. There is a method where you're involving P as the polynomial with the complex coefficients and positive degree, and you're involving Q's. That's more complicated. Polynomial equations. I'm keeping it basic, and we're just going to solve basic equations. in calculus, you will probably have to divide. You will have to know about bounce points, pass-through points. Regarding rational root theorem, college professors may require it. The best thing here is for calculus, when you're calculating a derivative one way, f of x minus f of x over, I don't want to embarrass myself and probably write it wrong, but if you're curious, those taking calculus, look up the difference quotients. If you had more time, I would have included a difference quotient I did last year, but you're going to be doing that in calculus. What's weird is they use the difference quotient to show you how to calculate the derivative. I did a little bit of this at the beginning of the year in the matrices unit, but then they show you other ways to calculate the derivative. It's almost like they're playing with you. I will look up the difference quotient just for you that are curious. Okay. So difference quotient. Shame on me. Well, actually, it wasn't that bad. F of x plus h. It actually was a little rough. F of x plus h minus f of x. So essentially, just like we did with when we discussed, I think it was the matrices unit. We want to get the derivative is the slope of the tangent line to the curve. So if you match some sort of line to a curve, remember when we did average rate of change? This f of x plus h would be your average rate of change. This is f of x, this is f of x plus h. So we do f of x plus h minus f of x divided by h. We simplify, we take the limit as h goes towards infinity typically, or towards 0. Actually, it would go towards 0 because we want to minimize this difference theoretically. And then we're left with this. Once we take the limit as h goes towards 0, this goes to 0. We're left with 6x minus 5. That's a good approximation for this line, 6x minus 5. Here we go with the limit as h approaches 0. So we're left with 2x minus 2. Difference quotient, look it up, get ahead on it. It's fun stuff. Yeah. Stop share. And this actually will help you out with that practice because you're going to get used to, again, a big issue with calculus is the algebra. Learning how to balance equations, combine like terms, simplify. All that math required in that difference quotient, this would be said practice. We're going back, I mean, look at all the steps required. Look at all this, look at all this. Dividing by, simplifying, all that stuff. It's relatively similar to what we're doing here, also dividing fractions, also relative to the rational unit, dealing with denominators and all that stuff. Okay, so here we go again, solving complex polynomial equations. I'm going to walk you through this step by step. Just like all quadratic equations, ax squared plus bx plus c equals 0. There's a relationship between c and b. There's also a relationship with a when we do this crosshatch procedure to factor. Numbers that multiply to give us c, sum up to give us b. Sometimes it's numbers that have something to do with this and this, still end up there. So let's practice this using the following steps to solve. We have this cubic equation. What is the product of the roots? How are we going to figure out what the product of the roots is? Well, our a is 1, so that's very helpful. We don't really have to worry about it. The product of the roots yields 75. The sum of the roots yield 13. The same way it does for quadratic equations, we just have to sort of go through more complicated steps, let's say. Okay. So let's work through this and see what's going on. What is the product of the roots? You can have 75 or you can have negative 75. And let's think about this. Let's think about what's going on here. If I set this equal to, if I solve this for 75, I get, or if I solve it for the x cubed, x squared, x function, I get x cubed minus x squared plus 13x equals negative 75. Generally speaking, your solutions, you have to consider that the positive or the negative would work. So what I do is I just literally throw a plus or minus sign in front of everything. So the next step, list all 12 possible integer roots by looking at the product of the roots. Here we're actually looking for factors of 75. What times what equals 75? Well, I know plus or minus 1 times plus or minus 75 equals 75. Let's think about other factors. I know 25 times 3 is 75. So plus or minus 3 times plus or minus 25 yields 75. Let's think about other things. And don't be ashamed if you need to pull your calculator out. 75 ends in 5. Let's look at this and see 75 divided by 5. That's another factor. 5 times 15. So we have plus or minus 5, and we have plus or minus 15. And let's think about, are there any other factors of 75 or negative 75? We're going to be focusing on the negative 75, by the way. I can't think of any. It ends in 5. 6 doesn't work. 8, 9, 10, 11, 12. Here we are. If there's a gap, so what? I'm able to do this little bookend thing where I have the lower one and the higher one. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 numbers we have to test. When I say test each value, a root, a solution, is essentially, what do I need to plug in for x to get 0? So testing each value means if I plug 1 in for every x in here, do I get 0? If I do, it's a solution. If I don't, I move on to -1. Then I test that plus +3, -3, +5, -5. I typically start with the smaller numbers. Because if this is a solution, something over here is a solution. But once I find one solution, I then divide. And then it'll be broken down into a quadratic. And then I could just use the quadratic formula. So let's test all these values. I'm going to start off with the +1. So let's plug -1 or +1 in for every x. I get 1 minus 1 plus 13 plus 75. I get 88. I should be getting 0, so we know 1 is not the case. Let's test -1. -1 cubed is -1 minus +1 minus 13 plus 75. Nope. Let's test +3. 3 cubed is 27. I need to have more faith in myself. 27 minus 9 plus 3 times 13 plus 75. That's not 0. Keep on going. Let's test -3. That's -27 minus 9 minus 13. I could also do plus 13 times -3 minus, it works out. So plus 13 times -3, parentheses, plus 75. Hooray, it works out. -3 is a solution, it is a root. Believe it or not, again, if you think this is cumbersome, look at this equation again, just to remind you. It's not that bad. It's not that bad at all. So, but we know one solution is that x equals -3. It works out. And we're done so far. Now this is what we do when we divide. We have to divide this function. This is x equals -3, so the factor is x plus 3 equals 0. So we have to divide this by, in this case, x plus 3. And remember, when we divide, our leftovers will be some quadratic. Then we can solve the simple quadratic equation. Or the quadratic function, yeah. So let's divide this. It's going to be x plus 3 divided by x cubed minus x squared plus 13x plus 75. And then we just divide out. What do I have to multiply x by to get x cubed? X squared. I get x cubed plus 3x squared. We're going to subtract these. Flipping in, let me bring in my pencil. This cancels out. Negative 1x squared plus negative 3x squared leaves me with negative 4x squared. Bringing down positive 13x. What do I have to multiply x by to get negative 4x squared? Negative 4x. Negative 4x squared minus 12x. Subtract these. Keep, flip, change. These cancel. I get 10, 20. I get positive 25x. And let me bring down this plus 75. Now I'm asking myself, what do I have to multiply x by to get 25x? Positive 25. So we have 25x plus 75. We have 25x, 25 times 3 is plus 75. We're going to subtract this. Keep, flip, change. This cancels. Oh, this cancels too. And this is another quality control check procedure. We know it's a root because when we divide it, we get 0. And that's how you know it's a root. It's a perfect, yeah. Another good thing is not only did we verify that this is in fact a root, we also simplified it into a quadratic. So the next step, we could simply solve this quadratic to get the other 2 roots. If you found an actual root, what should the remainder be in part D above? The remainder is 0. Write the 2 resulting factors of this cubic function. Those resulting factors are x plus 3 times x squared minus 4x plus 25. If you're curious, if we literally multiply this by that, we would get this cubic function. Think about it. X times x squared is x cubed. X times negative 4x is negative 4x squared. We would also have 3 times negative 4x. Also, if we continue to multiply out, we would get 25x. When we multiply this, we get negative x squared times negative x squared. We get 13x. Actually, it's definite. When I'm done solving this, I'm going to go ahead and just multiply this just so you know that it definitely works out. It's very good practice just to make sure we can do that. But let me go ahead and solve and get the other 2 solutions, the other 2 roots. All we have to do is solve this quadratic equation. So we have x equals 4 plus or minus. We're just using the quadratic equation, 2a hang low under negative b, all that good stuff. Remember, it's negative b, so negative 4 becomes positive 4. Square root negative 4 squared is 16 minus 4ac divided by 2 times a. When we solve for x, we get x equals 4 plus or minus 2i square root 21 divided by 2. If you need me to show you how we simplify that, let me know. Square root of 4 is 2. Let's look and see what 4 times 21 is. Let's just figure this out. 16 minus 4 times 25 is negative 84. 4 times 21 is 84. So the negative sign came out as the I. I factored out 4 times 84. So I pulled that 4 and took the square root of that 4. And the 2's out here, leaving 21 behind because 21 is not a perfect square. Oh my God. I'll get that later. So our 2 solutions are x equals 2, because 4 divided by 2 is 2, plus or minus I square root 21. Therefore, all of our solutions are x equals 2 plus I square root 21, x equals 2 minus I squared 21, and -3. We have 3 solutions for a cubic function. No surprise there at all whatsoever. Okay, so this is it. If you want to move on ahead to page 26, you can work and practice solving number 1 and check your answers, practice solving 2. For curiosity's sake, and also for practice, I'm gonna go ahead and distribute this just so you know we definitely do get a cubic function. So let's do x plus 3 times x squared minus 4x plus 25. And I'm gonna have to multiply everything by x and then everything by 3 and combine like terms. X cubed minus 4x squared plus 25x plus 3x squared minus 12x plus 75. When we combine like terms, I get x cubed. I get -4 positive 3 minus x squared. If I subtract 12 from 25, I get plus 13x, and then plus 75 equals 0. Voila, we know it works out. Okay. So that's page 25. Let's look at page 26. I'm going to go ahead and solve through this practice problem. Notice we have a cubic, or a quartic function. So when we have quartic functions, we're probably going to have to divide twice. I find one factor, I divide, I get a cubic. I find another factor, I divide, I get a quadratic. I can then solve. Let me go to a fresh page. Okay. So the first step to solve this extra bit of practice is we have to look at numbers that essentially are factors of 28. Generally though, if you simply throw plus or minus, you don't have to worry about if it's positive 28 or negative 28. But we do have to look at factors of plus or minus 28. So let's start off with, we know it's plus or minus 1, plus or minus 28. 2, it's even, so it's going to work, plus or minus 2. 2 times 14 is 28, so we have plus or minus 14. Let's see if there's another situation. I know 7 times 4 is 28 isn't divisible by 3. But I know 7 times 4 is 28, so let's do plus or minus 4, plus or minus 7. 5 doesn't work, 6, no, 7 we addressed already. And there's one trick. If you've already written a number here and you're going up consecutively, 1, 2, 3, 4, 5, 6, and you've achieved this, you have all the factors. There's no need in going forward. So let's go through and test 1, -1, 2, -2. It's easier to test these than these. So let's test to find one solution, one root. One number that when we plug it in for every x, we get 0. 1 to the 4th power minus 6 plus 3 plus 24 minus 28. Nope, that's not working out. So let's test -1. -1 to the 4th power is still positive 1. -1 cubed is -1. So that's really -6 times -1. So that's going to be plus 6, plus 3, minus 24, minus 28. Nope, that didn't work. Let's test positive 2. 2 to the 4th power, what's that, 16? Yeah, 16 minus 3 times 8 plus 3 times 4 plus 48 minus 28. Nope, that didn't work. Now let's test -2. That's still positive 16 minus 6 times negative 8, because it's an odd power, so it's going to end up negative. Negative 2 times negative 2 is positive 4. 4 times negative 2 is negative 8. Still plus 12. Yeah. Minus 48 minus 28. Oh, and look at that. We have 0. So we found one solution. X equals negative 2. The factored form is x plus 2. So we're going to divide this quartic by by x plus 2. So we have x. I'm going to switch to pencil here. We have x plus 2 divided by x to the 4th minus 6x cubed plus 3x squared plus 24x minus 28. We're going to divide and we're going to end up with the cubic function. So we're going to have to test other roots. The good thing is we can test that cubic function. It works out the same way. So I'm going to divide this, do this on your own, fast forward, do whatever you need. X cubed, x to the 4th, plus 2x cubed. Negative 8x cubed. So it's going to be negative 8x squared. Positive 16, 17, 18, 19x squared. Eight, 9, 10, 11, 12, 13, 14. Negative 14x, bringing down this negative 28. Negative 14. Negative 14x, negative 28. You know it worked out. That should be negative 14 times x. You know it worked out because we got 0. I like that. In case you made a mistake dividing, you know you have this quality control check procedure. So what are we going to do now? We're going to test this cubic function. I'd rather test the cubic function than the quartic because it's easier. We're going to have to test these roots again. Generally speaking, if 1 and negative 1 didn't work in the quartic, it's not going to work in the cubic either. But that's not always necessarily the case. So just to be sure, go ahead and check anyway. Another thing you can do is you can test these all over again here. That is something, but I'd rather test this cubic because it's a lot easier. So let's test this cubic function. It's not the end of the world. Let's go ahead and test this. We have testing positive 1. 1 minus 8 plus 19 minus 14. That's a no-go. Negative 1 minus 8 minus 19 minus 14. That's not working. Let's test positive 2. 8 minus 32 plus 10, 20, 38 minus 14. Oh, look at that. We got a 0. It's not that big a deal to test these points. Go ahead and test them. Once I get a root, I'm good. I'm done. I'm moving on. Because once I divide by the factor of this root, I get a quadratic. I'm done. So we know positive 2 is also a root. And that's what's interesting. Positive 2 didn't yield in a root necessarily. Let's do this positive 2 again. 2 raised to the 4th power minus 6 times 8 plus 12 plus 24 times 2 minus 28. It did yield in a positive power as well. How interesting is that? Yeah. Okay. Okay. So keep moving forward. We have x equals 2. If I solve, I get x minus 2 equals 0. We have another root we can solve for. We found that negative 2 works, and we can also find that positive 2 works as well. It doesn't matter which root you solve, whether you find the positive 2 or the negative 2 first, it works out either way. As long as we get some sort of factor, the whole point really is to whittle this down until it's a cubic function so we can use the quadratic equation. Whittle this down until it's a quadratic function so we can use the quadratic equation. We took the quartic function, minimized it to a cubic. Now I found another root that definitely gives me a 0. If I find out I made a mistake, by the time I'm dividing, I won't get 0. But if I get 0, I'll then have a quadratic left over. Then I can solve it that way. So this is x equals 2. This is the factor. So I'm going to divide this whole thing by x minus 2. So I have x minus 2. And I'm going to divide this cubic by it this time. X cubed minus 8x squared plus 19x minus 14. Here we go, do it on your own, fast forward whatever you need to do. X squared, 2x squared, red pen, keep, flip, change, cancels out, so it worked out. Negative 8, 7, negative 6x squared plus 19x minus 6x, negative 6x squared plus 12x, keep, flip, change, cancels out. 9, 8, 7, positive 7x minus 14. You can always see it coming together. Plus 7, 7x minus 14. Keep, flip, change, cancels out. 0. Good job, it works out. We know that's another root. So far we have a factor of x minus 2 and a factor of x plus 2. And we're also left with a quadratic that we could simply solve. So solving this here quadratic, I get x squared minus 6x plus 7, just to bring it down. X equals negative b. You guys should have this by now. Negative b plus or minus square root of b squared minus 4ac. So that becomes positive 6 plus or minus square root 36 minus 28, all divided by 2. If we simplify that, we get x equals 3 plus or minus square root 2. So our solutions are x equals positive 2, negative 2, 3 plus square root 2, and 3 minus the square root of 2. 4 solutions for a quartic equation works out pretty well, don't it? That's it. And that's 1. I'm going to leave 2 for you to do on your own and just check your work later. The same thing works out. It's just when we end up with our quadratic, we have an imaginary number I, but you all should know how to do that. We're still going to have 4 solutions. The answers will be posted for you to check. Show up to a tutoring if you have questions. Expect a quiz. Thank you. This is pages 24, 25, and 26. The next video will be pages 27, 28, and 29, dealing with de Moivre's theorem, connecting polynomials to circles in an interesting method. Thank you. Have a good day.